Welcome back. This video kicks off a series of videos that all focus on list methods. So Python comes with a bunch of these built-in methods that are particular to lists that allow us to do things like sort a list or split it in half or add a new item to the end or duplicate a list, all these different things that we can do. And there's just so many, I decided to split them up into a couple of bite-sized videos. But the first thing I want to address is the difference between functions and methods. They're both very, very similar. A method is just a type of a function, but there is a significant distinction. So we've been using built-in functions like print, print 1 plus 3, or len, which just a pet peeve of mine. I hate that it's just len instead of length. I don't know why that decision was made. Why don't we do pri instead of print? You just type the whole word, it's not that long. Anyways, we've been using len, and that is not particular to lists. We could use it on a string like this, and it gives us the length of that string. Or we could pass in a list as well, a single item list, and it tells us the length of that is 1. So unlike these built-in functions like print and len, the functions we're going to see in this video and the next couple videos are specific to lists. And the way we actually use them, the way we access them, is by adding a dot to the end of the name of a list. So we could have a list called data, like this, and we would access a list method by writing data dot whatever the method name is, dot append, dot sort. So everything we learn in these next few videos will be dot something coming after a list. And it doesn't have to be a variable name. You could do it directly on the list as well, but it has to be an instance of a list. We'll spend a lot more time talking about functions and methods later on when we actually cover them. But this is just one of those instances where I needed to do a little bit of explaining just to make sure that we are clear. Functions and methods are not exactly the same thing. They're not entirely interchangeable. Okay, so it boils down to the fact that when we have a function and it's attached to a particular object, in this case a list, it becomes a list method. If we have a function floating on its own, like print or len, it's just a function. Okay, enough of that stuff. We'll get back to it later on. Let's take a look at some of these list methods. So the first three we're going to talk about in this video all have to do with adding data to a list. And the first one is called append, and it will add an item, whatever we pass in, to the end of the list. So here's an example. I have first list is equal to the list 1, 2, 3, 4. And if I write first list dot append, because it's a method on a list, pass in 5, it changes first list to now have 5 at the end. So if we test it out, I have this data list already, 1, 2, 3, and I could do data dot append, and let's add in purple, of course. And now if we look at data, the list is 1, 2, 3, purple. So the fourth item is now purple. So that's pretty much it to append. It's a method on a list, so we have to use dot after the name of a list, and it always adds to the end of the list. So that's significant as well. You might be wondering, what if I have multiple things I want to append? Like I want to add in 2 numbers. Let's say I want to add in 7 and 9. Well, you cannot do 7, 9. If you try it, it says append takes exactly 1 argument, and I gave 2. So yeah, no, I'm not doing that for you, is what Python says. Fortunately, extend is to the rescue. So extend will add to the end of the list all of the values that we pass into it. So here's an example where we have this first list and we try to append multiple items. It does not work. Or if we tried to pass in another list, it actually just attaches the list to the end as a single item. It's nested inside. But if we do it the correct way using extend, it looks like this. So we have our first variable, correct list, equals 1, 2, 3, 4 in a list. If we call dot extend on that, and we pass in a list, a single list, 5, 6, 7, 8, it will take the items in this list and add them each to the end. So it doesn't just throw in the entire list as one item, it adds them individually. So let's try that. I'll make a simple list, and I'll just call it nums equals 1, 2, 3. So length of num right now, or of nums, is 3. If I did nums.append and I give it a list of 4, 5, what is the length of nums at this point? It's only 4. And that's because nums has 1 item, 2 item, 3 item, 4. This is 1 item. It takes up the 4th spot, or technically index of 3. But if we use nums.extend it instead, and we do the same thing, 4, 5, this time, if we look at nums, it's now an even 1 level list. So there's no nested list going on. So it just goes through the list and individually adds them in. And if we did length again, we would see this time that length is 5. So to summarize, if you're adding 1 item to the end of a list, use append. If you need to add more than 1 item to the end of the list, use extend. Both of these are great, but they only add to the end of a list. What if we want to add somewhere else, in the middle or at the beginning of a list? Well, thankfully, we have insert. So insert does just that. We tell it where to insert something using a numeric index, and then we tell it what to insert. So here's an example. We have first list. Once again, it's 1, 2, 3, 4 in a list. And then we call the insert method on that list. And the first thing we provide is the index we want to add the new data to. So that is 2 in this case. So 0, 1, 2. So it should be right here at this spot. And what do we want to add? The string high. So our result is 1, 2, high, 3, 4. So it's the index, remember, starts counting at 0. So 0, 1, 2. We can also use negative numbers along with insert, but it might not work exactly the way you anticipate, because when we do -1, if we ask for the -1th item, the -1st item of this list, it would give us 4. But in this case, it's going to calculate the index based off of the existing list before this is inserted. So this list is 0, 1, 2, 3, 4. The last index is 4. Also, the item itself is 4, which is confusing, but this is the 4th position. So when we access -1, we say insert this at the last position. It's going to figure out on the old version of the list. That means 4, index 4. And so it adds the end to index 4, which really means 0, 1, 2, 3, 4. And it's not actually accounting for the fact that the list grows by 1. So it doesn't add it to the very end. It will add it to the second to last thing. If you want something to be inserted at the very, very end, what you could do is this. If we had nums equals 1, 2, 3, 4, I could do nums.insert. And if I didn't know how long the list, I could just use append, but if you wanted to use insert and you didn't know how long the list is, you can do len of nums, comma, last, or whatever we want to insert. So this is going to calculate the length of it. And if we look at nums now, it shows up last. I wouldn't focus on it too much, but I just wanted to point out that it may not work exactly the way you expect. But otherwise, it's pretty straightforward. You give it the index you want, and then the piece of data to insert. And if you're trying to add something to the end, then just use append. Okay, so let's wrap all of that up. We learned 3 methods. The first, append, will add a single item to the end of a list. And then we have extend, which will add multiple items to the end of a list only. And then finally, insert. If you need to add an item anywhere else that isn't the end, you can use insert. Cool. So next up, we'll focus on deleting things from our list. A couple of methods to do that.